Hi, this is Megan Dowd. This is my week 7 assignment 2 for using the Monte Carlo method to estimate the overlap area of two ellipses. So I'll start by running my file. This will demonstrate the code on 2 different examples to show how the approach works for both simple and more general cases. So in the first example, I just use 2 circles, which we can see over in demo simple case. So 2 simple circles, which are a special case of ellipses where both foci are at the same point. One circle is centered at the origin and the second is shifted slightly to the right, so the 2 shapes partially overlap. And then in the second example, I use 2 true ellipses with different sizes, focal points, and orientations. These ellipses are rotated relative to each other and overlap in a less symmetric way. In both cases, I use the same algorithm. The program randomly samples points in the bounding box and estimates the overlap area by counting the points that fall inside the both shapes. The fact that the single approach works for both the simple and complex cases shows the quality of the implementation. So to talk a little bit about the structure of my code, it begins with a with a custom pseudo-rando number generator implemented using a linear generator. So that is up here. This replaces Python's built-in random module and satisfies the requirement to leverage a pseudo-random generator. Next is the point class. So this represents a point in 2-dimensional space and provides a method for computing the Euclidean distance. Then we have the ellipse class. This is defined by 2 foci and the length of the major axis. It computes derived quantities such as the center, the semi-major axis, the semi-minor axis, and the orientation of the ellipses. To test whether the point lies inside an ellipse, the code uses a geometric definition of ellipse, which is a point is inside the ellipse if the sum of its distances to the 2 foci is less than or equal to the major axis length. And then we have the Monte Carlo accept reject loop. So this is the compute overlap of ellipses. First, the code computes an axis-aligned bounding box that fully contains both ellipses. It then repeatedly generates random points inside the box using the custom pseudo-random generator. For each sampled point, the code checks whether the point lies inside both ellipses. Points that satisfy the condition are counted and accepted. The overlap area is estimated by multiplying the bounding box area by the fraction of accepted points, which is a standard Monte Carlo accept reject method. So that includes my demo for this assignment. Thank you.